Hello, PreCalculus. Welcome to section 1.6. We have two things to talk about in 1.6. One is operations of functions. The other one is composition of functions. So to start us off, we've got operations of functions. We've got four different operations we could do, which is addition, otherwise known as sum. We can find the difference or subtract two functions. We can multiply two functions and find the product. Or divide two functions, as long as g of x is not 0, or as long as the denominator is not 0, we can divide the function, and that's called a quotient. So they gave us three different functions here, and then they're giving us several different operations to use with them. So A says find f of x plus g of x if f of x is equal to x squared plus 4x, and g of x is equal to square root of x plus 2. And we also need to find the domain of the new function, right? So f plus g, I'm just going to take my f of x, and I'm going to add to it my g of x. So this would be x squared plus 4x plus the square root of x plus 2. That's all it means for f plus g of x. Now, the trickier part comes when we're trying to find our domain. Well, we have to worry about the domain of each piece. X squared is all real numbers, no restrictions. X, all real numbers, no restrictions. But what did we say about this guy for the domain? Underneath the square root, it has to be greater than or equal to 0, right? So that means x has to be greater than or equal to negative 2. So the domain for our new f plus g of x function is going to be from negative 2 to infinity, including that negative 2. It's okay to have the square root of 0, right? Square root of 0 is 0. All right. For f minus h of x, now I'm going to take f of x. I'm going to subtract from it h of x. That's going to be x squared plus 4x minus, be careful, we want to subtract it the whole thing. So when we subtract, we've got to distribute that negative sign to each piece in there. So this is x squared plus 4x minus 3x, and then minus a minus 5 becomes positive 5. So that's x squared, 4x minus 3x is x plus 5. As far as the domain goes for this piece here, f minus h of x, its domain, do we have any restrictions for x squared or for x? No, I can plug anything we want to in here. No fractions, no square roots, so this one is safe to be all real numbers. All right, f times h of x, well, I need to be able to see these guys real quick. I'm going to take f of x, which is x squared plus 4x, and I'm multiplying it times h of x, which is 3x minus 5. All right. So x squared times 3x, that's 3x cubed. X squared times negative 5, that's negative 5x squared. 4x times 3x, that's 12x squared. 4x times negative 5 is negative 20x. So I combine some like terms in here. I've got 3x cubed. 12 minus 5 would be 7x squared minus 20x. That is f times h of x. Do we have any restrictions? Ask yourself, do you see any fractions? Do you see any square root signs? Nope. So therefore it's going to be all real numbers. All right, h of x divided by f of x. My h of x is 3x minus 5. My f of x would be x squared plus 4x. And I can leave it just like that. What do we have to worry about now, though? We've got a fraction, right? So what can't be true with our fraction? The denominator can't be 0. So this guy here can't be 0. Well, I'm going to solve this guy and figure out what are those specific x values. So I can say x can't be 0, and, well, sorry, let me factor this just so I can show my steps. What do these guys have in common? They both have an x, so I've got x plus 4 can't be equal 0. And now I can split it up into my two equations. X can't be 0, x plus 4 can't be 0, so x can't be negative 4. So my domain for this one is the set of all x's such that x can't be 0 or -4, but it can be any other real number. What kind of notation is this? Set notation. For interval notation, that would be -infinity to -4, union -4 to 0, union 0 to infinity. All right. Go ahead and pause your video. Once you see, here's f of x, here's g of x. You can't see all of them, but find f plus g of x, find f minus g of x, f times g of x, and f divided by g of x. Go ahead and pause your video, see if you can get these 4. All right, welcome back. Let's add these guys together first. We've got x minus 4 plus the square root of 9 minus x squared. That's f plus g of x. The only thing I'm worried about for my domain is this guy over here can't be negative, so 9 minus x squared has to be greater than or equal to 0, which means 9 has to be greater than or equal to x squared. When I take the square root of both sides, I get 3 greater than or equal to plus or minus x. All right, so either 3 is greater than or equal to x, or 3 is greater than or equal to negative x. Dividing by the -1, don't forget to flip your signs, x is greater than or equal to -3. So that's typically backwards of how we write everything, but 3 is greater than or equal to x means that 3 is actually, writing it the same way, x is less than or equal to 3. So I just flipped everything over, right? Same thing down here, I want to get x on this side, so it's used to what I'm saying. So x is greater than or equal to, right? -3. So x is less than 3, and x is greater than or equal to -3. This is a case, if you have a hard time visualizing it, put it on a number line. I can be 3, I can be -3, I can be greater than -3, but I also have to be less than 3. So this is what we call a sandwich one. So my domain for this one is going to be sandwiched between -3 and 3. Interval notation would be looking like that. That's everything in between. All right, f minus g of x. I've got x minus h minus the square root of 9 minus x squared. Has anything changed with our domain? No, right? Because now we're still worried about that square root of 9 minus x squared. So it's going to have the same domain of x is sandwiched in between -3 and 3, including both of those numbers. All right, for f of x times g of x, I've got x minus h times, not x minus h, x minus 4 times the square root of 9 minus x squared. If we want to get all fancy, we could say, well, that's x times the square root of 9 minus x squared minus 4 times the square root of 9 minus x squared. I guess you could go that far. That's not any more simplified in my world, but that'll work. What is our domain again? What is the one thing we're worried about? That square root. So the domain for this guy is the same, from -3 to 3. And last but not least, f divided by g of x would be x minus h divided by our g of x, which is the square root of 9 minus x squared. All right, now I've got the square root, but where is that square root at? It's in the denominator. So now can x be equal to 3? Right? So now instead of it having to be greater than or equal to 0, this guy can't be 0. Yes, I can still have the square root of 0, but can the denominator of this fraction be 0? No. So now it's got to be strictly greater than. And so how does that change our guy here? Can we have these endpoints? Can it be equal to these? No. So instead of my domain being -3 to 3, including my endpoints, I'm going to have the open interval -3 to 3 because I can't be included at either of those guys. All right, that's it for function operations. Coming up next is composition of functions.